If you remember the Great Quebec Blackout of March 1989, when a geomagnetic storm plunged 6 million people into darkness for 9 hours, then you'll understand why what happened this week matters. Because the sun just delivered multiple X-class solar flares, the most powerful eruptions it can produce, and unlike 1989, we got lucky. These were warning shots. Between November 4th and 9th, 2025, our star unleashed a sustained bombardment that knocked out radio communications across 2 continents, triggered G3 geomagnetic storms, and painted auroras as far south as northern Mexico. Airlines rerouted polar flights. Satellite operators scrambled to adjust orbits. Power grid managers made emergency voltage corrections. But here's what should concern us. Active Region AR4274, the source of these eruptions, has now rotated into a geoeffective position. Earth stands directly in the firing line. Let me walk you through exactly what happened. November 4th, 12:34 p.m. Eastern Time. Sunspot region AR4274 exploded with an X1.8 solar flare. The electromagnetic burst traveled at the speed of light, 8 minutes from Sun to Earth. It triggered what NOAA classifies as an R3 radio blackout. That's strong on their 5-point scale. Across North and South America, high-frequency radio communications simply ceased. Aviation, maritime operations, emergency services that depend on HF bands, all experienced disruptions lasting up to an hour. The ionosphere's D layer, normally transparent to these signals, became opaque as solar X-rays ionized the lower atmosphere. But AR4274 wasn't finished. 4.5 hours later, 5:02 p.m. Eastern, a second X-class flare erupted, X1.1. And here's what made this remarkable. It came from a different region entirely, one still hidden beyond the sun's southeastern limb, most likely AR4246 or 4248, returning from their previous journey across the visible disk. This second blast knocked out radio across the North Pacific, New Zealand, and Eastern Australia. 2 X-class flares, different regions, less than 12 hours apart. We hadn't seen paired eruptions like this since the historic solar maximum events of the early 2000s. And both flares launched coronal mass ejections into space.
The cascade had begun.
Now, if you've followed solar physics for any length of time, you know that X-class flares are just the opening act. The real danger comes from what follows, the coronal mass ejections. On November 5th, AR4274 produced an M7.4 flare at 11:19 UTC, not X-class, but powerful enough to launch a full halo CME. When you see a full halo in coronagraph imagery, when the ejection appears to surround the entire sun, that's your signal, it's heading our way. Space weather forecasters at NOAA immediately began modeling its trajectory. The plasma cloud, traveling at 744 kilometers per second, nearly 500,000 miles per hour, would reach Earth within 48 hours. Later that same day at 22:07 UTC, an even stronger M8.6 flare erupted from the same region. AR4274 was in overdrive, firing almost continuously throughout November 5th and 6th. Multiple CMEs, now racing toward Earth's orbit. Some would miss, others would deliver glancing blows, but at least 2 were on direct collision courses with our magnetosphere. Then, on November 9th at 7:01 UTC, AR4274 unleashed another X-class event, X1.8, another asymmetric halo CME, directly Earth-directed. Arrival forecast November 11th. The question wasn't if we'd be hit, it was how hard. The first CME struck on November 6th. NOAA had predicted G2 conditions, moderate geomagnetic storming, but the storm's intensity surprised forecasters. By 5:27 UTC, we had reached G3 levels, strong geomagnetic storming. Let me put that in perspective. At G3 intensity, several things happened simultaneously. Solar wind speed surges from 350 to over 600 kilometers per second. The interplanetary magnetic field strengthens from 6 nanoteslas to 14. And critically, the BZ component, that's the north-south orientation of the magnetic field, turns sharply southward to -14 nanoteslas. For those who understand magnetospheric physics, you know what this means. When the interplanetary magnetic field points south, it can reconnect with Earth's northward-pointing field. This opens a pathway. Charged particles stream into our magnetosphere, and then the impacts begin. Power grid operators across high latitudes had to make voltage corrections to prevent system damage. Low Earth orbit satellites experienced increased atmospheric drag, in some cases drag increased by up to 400%. Orbital decay accelerated, collision warnings multiplied, satellite operators burned precious fuel to maintain altitude. GPS signals at northern latitudes? Degraded. If you were navigating in Canada during the storm peak, your position could have been off by several meters, not enough to notice on a highway, but for precision agriculture, surveying, potentially critical. Airlines rerouted polar flights because high-frequency radio communication became unreliable. When you're flying over the Arctic, you can't afford to lose contact with air traffic control. And across the northern tier of the United States, Pennsylvania, Iowa, Oregon, people stepped outside to see something many had never witnessed. Green and purple curtains of light dancing across the sky. Aurora borealis, visible despite the bright glare of the year's largest supermoon. Reports came in from observers as far south as northern Mexico. The KP index, which measures geomagnetic activity, peaked at 7. Some monitoring stations recorded brief spikes, suggesting we nearly touched G4 conditions. We were one magnetic field orientation away from something significantly worse. Here's what you need to understand. We dodged a bullet this week. These CMEs hit us with glancing blows. The magnetic field orientations weren't optimal for maximum damage. If that BZ component had stayed southward for 12 hours instead of 3, if the plasma cloud had been twice as dense, we could be talking about the Quebec blackout all over again. But AR4274 is still there, still active, still complex, now pointing directly at Earth. The CME launched on November 9th is currently en route. Forecasters expect arrival late on the 11th. NOAA has issued geomagnetic storm watches extending through November 12th. Minor to moderate storming is likely, G3 conditions remain possible. Beyond that, other active regions are developing on the sun's eastern limb. We're approaching solar maximum, the peak of solar cycle 25, and our star appears intent on reminding us of something we sometimes forget. In 1859, the Carrington event, the strongest solar storm ever recorded, struck when humanity barely had telegraph lines. Operators reported sparks flying from their equipment. Telegraph paper caught fire. Aurora were visible at the equator. Today, we have power grids spanning continents. GPS satellites guiding everything from your car to commercial aircraft to precision farming equipment, communication networks that modern civilization depends on, financial systems, internet infrastructure, all of it vulnerable. This week wasn't the big one. The orientation was wrong. The density was manageable. We had time to prepare. But it was a reminder. We don't live on Earth. We live in the sun's atmosphere. We're inside its sphere of influence. And when it decides to flex its power, all our technology, everything we've built, becomes fragile. The sun continues to teach us, and we'd better keep learning. Because next time, the magnetic field might point south for 12 hours instead of 3. Next time, the plasma density might be twice as high. Next time, we might not be so fortunate. Keep watching the sky, and maybe keep a flashlight handy.